I will now go and import a color image and look at some of its features, and especially those that distinguish it from a gray image. So the first thing to do is to import some functionality from the image library, import imread, and from pyplot import subplots, both from matplotlib. And we can, once that's imported, we can get our image from imread by specifying the path and the image name. So the path I have is in an image in a subfolder called figs, and the image that I want to select is of those that I have here called cerebellum 2.jpg. So it's a JPEG image. I can display it by using subplots, and I can specify the figure size as 20 by 10, a fairly large image, and then access the axis, use imshow to display the image, and call that variable, and here it is. So this image is a slice of the cerebellum, and you can see it's a color image. It contains some color, and specifically the color is used to denote certain anatomical areas here. So if you use imread to import an image file into Python, and you can check the type that you get for that array, and it's a NumPy array. So, and if we know it's a NumPy array, we can access, of course, all of its features with the known functionalities. So image.size will tell us how many pixels there are. So there's 150,000 or so pixels. And if we check for the shape, we can see that there are 154 rows and 327 columns, which I think you can see. If I zoomed into that image, you would see that this is actually what is displayed here by default. So knowing what the rows and columns are, we can of course zoom into it, and specifically we can check what the numbers look like, for example, in the yellow area. So let's zoom into the yellow area, remembering that in terms of rows it's around index 16, in terms of columns it's around index 100. So let's just see some of those numbers. So 60, if we have row 60, we can go from 60 to 70, and we can go in columns from 100 to 110. And then we display all of the last column in order to find out what they are. Right, so you can see you have 10 blocks of 10 rows each, and each of the rows has 3 numbers in it. So that actually means that we have now 3 slices of length of rows and length of columns on top of each other, so to speak. And the convention used here is that those 3 slices of that image represent different colors. So in order to get the final color, you mix 2 color components, and in this case it's using RGB convention. So the first slice gives you the color for the red component, second for the green component, and third for the blue component. So let's just see that central slice as we have it. Let's see what it looks like. Let's have a display of it. Subplots. And then we have x.imshow. See the image and use the image sliced at this sliced for that little section in the center. And what we can see that little section in the center, which was yellow in the original image, if I just go up down, so we're somewhere here at the center of this anterior lobe of the cerebellum. And then we can see it's all yellow, but there are different shades of yellow. Right? So there's brighter yellow and darker yellow and so on. And of course that makes that specific pattern that we find there. And yellow is achieved by overlaying the individual layers of colors. So to understand the layers in terms of their color contribution, let's just see all of the elements of that array. And this is how you see all of them, right? These are all of the rows and all of the columns. And what I can do now, I can show you the layers one by one. So if I do that, I'll show the first layer, which is R, so standing for red, but I specify the color map as being gray because that's only one layer. This will now not compose a color, but will just be a sort of a grayscale image, and means we'd rather display it as black and white. So what you can see in the red layer, that there are a lot of components, say in this posterior lobe here, which are very dark or black, and that means the red contribution there is very low, right? Because black is 0 and dark means small values in that array at the pixels representing this area. And on the other hand, so we can see rather that yellow area, that anterior lobe, is much brighter, showing that the red component is much stronger there. Let's go to the green component, which is layer number 1. So that looks different now. These are brighter in the posterior lobe and still very bright in the yellow part that represent the anterior lobe. And finally the blue. The blue contribution has a very low part or very dark area in this gray display in the anterior lobe and somehow neutrally gray over here, and is also a low contribution in the posterior lobe. So, and that is the meaning of how these three contributions from these three different colors are then overlaid in the RGB convention in order to produce that final image.